Okay, so let us discuss some few properties related to inverse Laplace. So, what is inverse Laplace of derivative? See, in the Laplace transform, we have seen multiplication by power of t. What is that? Laplace of t into f of t. This is multiplication by power of t. We have seen that this is minus into d by ds of f of s. Okay, we are just taking the inverse of this. We'll get the inverse Laplace of derivative. That's it. So inverse Laplace of f of s is equal to f of t. Then inverse Laplace of d by ds of f of s is nothing but minus t into f of t. We just shifted this minus sign into the right hand side. Okay. So to understand this, let us see the example. So whatever the Laplace of multiplication by power of t, it is inverse Laplace of derivative here. Okay, so just interchange of the property. Laplace of multiplication by power of t, it is here inverse Laplace of derivative. Okay, so what is the example to understand this? Suppose if we have to find out the inverse Laplace of suppose we have just find inverse Laplace of cot inverse of s. What is the inverse Laplace of this? Okay, so suppose this inverse Laplace of cot inverse of s, suppose this value is nothing but f of t, for example. Okay, because we don't have any formula related to this type of f of s in the standard results, we may have to use some property, and that property is inverse Laplace of derivative. So therefore, by inverse Laplace of derivative, what we have, take the derivative. So if we apply the derivative, so what I will get, so this is d by ds of this f of s is nothing but what, cot inverse of s. This is equal to what, the property says that once if we have the derivative in the inverse Laplace of f of s, then there is a minus t multiple with f of t. So see what are the changes in this side, it is minus t into f of t, isn't it? So by using inverse Laplace of derivative. So what is the inverse Laplace of what is the derivative of cot inverse of s? So this is inverse Laplace of, this is simply minus 1 upon s square plus 1. Derivative, what is the d dx of cot inverse of x? Cot inverse of x. This is equal to what? 1 upon minus 1 upon x square plus 1. This is the derivative. So that I have used here. So this is simply equal to minus t into f of t. So minus sign get cancelled on both sides. And what is inverse Laplace of 1 upon s square plus 1? It is nothing but sine of at. Sine of a means 1. But sine of t. This is equal to t into f of t. Isn't it? And what is my answer? So the my answer is simply we want f of t. So therefore, what is f of t? F of t is sine of t divided by t. That's it. See, I have used the Laplace of sine t here. What is Laplace? Inverse Laplace of 1 upon s square plus a square. This is nothing but 1 upon a into sine of at. This is what I have used here. Okay. So I just have this sine t instead of that. Inverse Laplace of minus minus get cancelled on both sides. Okay, so this is nothing but a inverse Laplace of derivative, if you have understand. Now next is inverse Laplace of integral. What is inverse Laplace of integral? So if you have seen inverse, so if you have seen Laplace of division by t property in the Laplace transform, so what is that? It is s to infinity f of s into ds. So same here that I have used. Okay, just take the inverse of this, you will get this. Okay, so nothing is different. Whatever the Laplace of division by power of t, it is inverse Laplace of integral is here. Okay, so inverse Laplace of f of s into inverse Laplace of f of s is equal to f of t. Then inverse Laplace of f of integral f s to infinity f of s ds is nothing but f of t upon t. Okay, so to understand this, let us see the example. So find inverse Laplace of this 2s plus 1 divided by, suppose it is s square plus 2s plus 1 bracket square. What is the inverse Laplace of this? Okay, so let the inverse Laplace of this is nothing but 2s plus 1 divided by s square plus 2s plus 1 bracket square. Suppose this value is nothing but f of t. Okay, so to just calculate this, we need to apply. So here apply inverse Laplace of integral. What is that? Inverse Laplace of integral. So this is nothing but inverse Laplace of integration s to infinity 2s plus 1 divided by s square plus 2s plus 1 bracket square ds. And once if you take the integral, so therefore t is there in the denominator of f of t by using inverse Laplace of integral. Got it? So now what is the integration of this? Because if you see, if you take the derivative of this, so suppose, just let me understand, let me explain you about this. So if we take the derivative of d ds or d ds of 1 upon s square plus 2s plus 1, what is the derivative of this? Okay, so see, what is the d dx of f of x? D dx of 1 upon fx. This is equal to what? Minus 1 upon fx square into f dash of x. Got it? So function is s square plus 2s plus 1. So this is minus 1 upon s square plus 2s plus 1 bracket square into derivative of this 2s plus 1. Got it? Okay. So therefore this is nothing but minus 2s plus 1 divided by this is s square plus 2s plus 1 square. And if we take the integration of this, you will get this. Okay, so now we are taking the integration of this minus sign, we just shift, and what I get here. So with this understanding, now we have the derivative, we have the integration. Okay, so therefore integration of this is nothing but this is inverse Laplace of 1 upon minus 1 upon s square plus 2s plus 1. This is equal to f of t divided by t. This is my integral. This is my answer. Now we just need to adjust some things here. Okay, because we don't have the proper answers here. Okay, so basically 2s plus 1 is here. So this is not 2s plus 2 either. 2s plus 2 is here. This is 2s plus 2, not 1. Because if we have the derivative, this is derivative of s square plus 2s plus 1 is nothing but s square plus 2, 2s plus 2. Okay, so that's why this is there minus 1 upon s square plus 2s plus 1. That's it. Now, so what is the inverse Laplace of this? So minus sign we just shifted over here. So this is nothing but inverse Laplace of what is the expansion here? It is s plus 1 bracket square. Okay, so this is nothing but minus f of t divided by t. That's it. Okay, so s plus 1 bracket square, it is minus sign we have shifted. Now you just change the first shifting theorem here. So by first shifting theorem, what we need to do, we need to shift this e raised to minus t outside, inverse Laplace of 1 upon s square. This is nothing but minus f of t upon t by first shifting theorem. What is that first shifting theorem? The first shifting theorem is what? So Laplace, inverse Laplace of f of s plus a is nothing but e raised to minus at into f of t, like this. So minus a is nothing but 1. We are replacing replace s plus 1 by s. Wherever that s plus 1 is there, we are replacing it by s, and this 1 a we are shifted in the power of e. That's it. And we know what is the inverse Laplace of 1 upon s square. What is the inverse Laplace of 1 upon s raised to n? So inverse Laplace of 1 upon s raised to n is nothing but e raised to n minus 1 divided by n minus 1 factorial. Okay, so inverse Laplace of 1 upon s raised to n is nothing but t raised to n minus 1 divided by n minus 1 factorial. And therefore, what we have e raised to minus t as it is. This is t raised to 2 minus 1 divided by 2 minus 1 factorial. This is equal to minus f of t upon t. And finally, what we have, this is t raised to 2 minus 1 is nothing but t. 2 minus 1 factorial is nothing but 1. Okay, so this is t e raised to minus t. This is equal to minus f of t divided by t. And minus and this t we just shifted here. And from this, what I have, f of t is equal to, f of t is equal to what? Simply t square into e raised to minus t, minus of course. Okay, so in this way we can easily find out what is the inverse Laplace of integral. Okay, hope you have got this.